Hey everybody. I first of all want to acknowledge CUDA Software for making the following questions possible. This is a practice final exam that I put together. It should be useful to anyone taking a geometry class who has an exam coming up and wants a general overview of some concepts that most likely will be covered at a Geometry A level course. Okay, so here we go. We're going to start with this first question here. In this question, we can see that we have an angle that has been divided by array LR. There is some information over here that is definitely noteworthy. So I'm going to go ahead and just underline it, and we can go ahead and mark it after that. So what I'd like to do is to transfer the information into the diagram itself, so it's easier to see what's going on. So the measurement of angle KLR is 22x. That would be this angle right over here. So I'll put 22x right there, excuse me. And then the measurement of angle KLM, that whole angle is 30x plus 2. So just using a different color, this entire angle from here all the way to there, that one would be 30x plus 2. This first one that I marked, that's only this piece right there. Then the measurement of angle RLM is 42, and that would be the other angle that we have here, which is this would be 42. So this is definitely a question about the angle addition postulate, which says now when you have an angle that's been divided into two or more angles, then the sum of those smaller angles equals the whole angle, the largest one. So based on that idea, I'm going to go ahead and say that 22x plus 42 degrees is equal to the entire thing, which is 30x plus 2. And then from this point, it's back to algebra 1a and solving a regular equation. So just taking some shortcuts, if I were to subtract 2 on both sides and move the 22x to the other side, I would get 40 is equal to 8x, and that means that x is now 5. Now, this doesn't mean that it's 5 degrees, because none of the angles are called just x, but the value of x, which allows us to get the value of an angle, that value of x is 5. Now, that's all we have to do here is find x, and we did. It's right over there. So that would be the end for number 1. Going on to number 2, here we have to solve for x once again. This question is definitely about parallel lines and the angles created by the transversal going through them. And I know that these lines are parallel because I can see these two red symbols here tell me that these lines are parallel. So the way to approach this is by first understanding the types of angles that we have. So this angle here and that angle there, given their positions, these are on opposite sides, and they are both on the exterior or the outside of the parallel lines. These are alternate exterior angles, which are the cousins of the alternate interior angles. And that means that they are definitely congruent to each other. So being congruent, all I have to do is set up an equation which says that this angle measurement is the same as this one, and all I need to do is find out the value of x, which turns 115 into 110. So subtracting 115 from both sides, I get that x is negative 5. And just like that, it's done. Number 3. So we have to find the value of x yet again. The trick to this is knowing what kind of angles we have looking at us here, and these would be vertical angles, which means that they too are congruent. So as you say it is the way you write it. So this would be 3 plus 4x is simply equal to 79 degrees. And then with a little fancy footwork here, we get 4x is equal to 76, and dividing by 4 on both sides, that would be 19. And again, it's not 19 degrees, it's just x is equal to 19. That's the value that you would plug into this x right there. And by doing all the math that is inside these parentheses, you should expect to get 79 as a result because they're congruent. Okay, number 4, on to the next one. Oop, that's number 5. Number 4, these are two complementary angles. And all that means is that this angle and this angle, they add to equal this red value here, which is 90 degrees. So all you have to do is create an equation which says that the sum of the two angles creates that 90 degrees, and that would be 2x plus x minus 9 is equal to 90. They're complementary. And then you solve. So 3x here, if you move the 9 to the other side, you get 99, and that means that x is 33. Okay? Once again, it's just the value of x. To find out what the value of the angle is, you plug in the 33 and do the math. Okay, on to the next. So number 5. In this example here, this would be perhaps a little trickier, but these two angles are definitely related to each other. Otherwise, they wouldn't be there. And once again, I'm noticing that there are these symbols here which indicate that the lines that they're on are indeed parallel. And that's good news, because without that information, I should not assume that they are parallel. And what that allows me to do is to say that these two angles are alternate exterior angles, which means that they're congruent. So 59 degrees is equal to 2x plus 1. Subtracting 1 on both sides gives 58. And that means that the value of x is equal to 29. Okay, and again, if you want to find out the value of this angle, look there, because they are congruent. That means that you know this is going to be 59, and this 29, which is the value of x, would help you get that. All right, on to the next. Number 6 is a good question. This one over here is definitely, again, angle addition postulate. This, if you're thinking this looks almost like a circle, and that's because it almost is. And that blue section arc there that I just completed, that is made up of these two angles, which you see there and right there. And so if I know the whole thing is a circle, if you consider this exterior angle, that means that if you were to take all three angles and add them together, you would get 360, because that's the degree in a circle. So that means I need to say 27 minus 17 plus x, and then plus 6x is equal to 360. And then after this, it's just a matter of solving. So combine like terms. So that's 7x. This would be plus 10 equals 360. And then 7x is equal to 350. And if I did my math right, which I think I did, this means that x is equal to 50. Okay, and once again, this is not the value of the angle. It's just the value to help you get the angle. So you'd plug it in there, and you'd plug it in right there. And then you could figure out the value of each of those angles if you wanted to, which you don't in this case. Number 7. Okay, these two angles here are definitely related in terms of parallel lines. These two lines are parallel. And so the way that these angles are sitting makes them both same side interior angles. So if you remember, same side interior angles are always supplementary, which means that they sum to equal 180. So the way you say it is the way you write it, and that means that this would be 23x minus 5 plus 13x plus 5 equals 180. And at this point, again, it's just back to algebra. So by just combining like terms and moving things around, you get, this would be 36x. The two 5s basically wipe each other out, right? And then you get 36x is equal to 180. And by dividing by 36, you should get the value at 5. So x is 5. Okay. All right. So I hope this is helping so far. Moving on to the next one. Again, parallel lines. Due to these symbols here, the symbols are important. So be sure to notice the symbols, because they're a great guide to know how to relate the angles and the other information that you're given. So given that these are parallel to each other, what that means is that if you look at where these angles are, one is on the interior, one's on the exterior, yet they're both on the same side, then the relationship between them is simply that they are congruent. And the names of these angles are corresponding angles because they correspond to each other. So this would be, the way you say it is how you write it. So 6x minus 7 is simply equal to 53. So that means that you already know this angle measurement is going to be 53 degrees. We want to find the value of x which creates that 53 degrees. So that's our task here. So again, here's the equation, and then you just solve it. So 6x is equal to 60, and that means that x is now 10. Okay, so if you were to plug this in right there, you would get 60 minus 7, and that would give you 53. All right, moving on. Number 9, right here. So in this one, you have to name all the angles that have a vertex V as a vertex. Now, to name an angle means you have to first look at how it's set up. Is it numerical? Is it by points? How many angles are involved? Is it one angle, or is that one angle divided into several other angles? So in this case, we have an angle that is divided into several other angles, and they're named both numerically and with points along the rays. So we have to account for all of that. When we name the angle, we have to be sure to name it in all the ways that you possibly can. So I'm going to start with the largest one, which is this one here. And this vertex V has to be the point that is in the middle of those three letters. So this first one would be angle, HVK. The next one would be, just go from left to right. So this would be angle, HVI. That would be that one. And then the next one, if you go this way, that would be angle IVJ. And I'm just moving left to right. Sorry about that. Left to right. All right, that angle would be angle JVK. And that uses up all the letters. Now, we also have numbers, as you can see over here, here, and here. So you can name a specific angle either by 3 points, putting the vertex in the middle of those, or you could just name it by the number. So this first one over here, which was also called angle HVI, this is also called angle 2. You can just call it angle 2. This one over here, which is also known as angle IVJ, we can also call this angle 3. This one over here, which is also known as angle JVK, we can also call that angle 4. Okay, so angles do go by either numbers, or they go by a single letter if you have just one angle, or they go by 3 letters if you have multiple angles that are sharing the same vertex. All right, this next one will be the last one for this video. I am running out of time on this, and so I will have to create another video with the rest of these questions after number 10. For this one, I'll give you the setup, and this is the way it goes. Actually, this would be this can be done in 2 ways. So this is 90 degrees. This belongs right there. It's just too small a space to fit it. So that's why it was put like that. There are 2 ways to do this. One way is to realize that these are vertical angles. So you can call this 2x plus 13. And then the sum of all the interior angles of a triangle is 180. So you could say 2x plus 13 minus 11 plus 6x plus 90. All this is equal to 180, and then you can solve it. Or you could use what's called the Exterior Angle Theorem, which simply says that the angle outside of a triangle is simply equal to the sum of the 2 remote interior angles, which would be these 2. So another way to set it up would be to say 2x plus 13 is equal to negative 11 plus 6x plus 90. And then you would solve that and get the answer. So both would give you the same answer, just a different way to get it. And with that, I'm out of time, so I'm going to have to stop the video. Please check out the follow-up to this one, and I will cover more questions after number 10. Thanks for watching. Bye-bye.